Hello, it's Algebra, all algebra students. Mr. Lawrence here with your next flipped lesson. We've talked about linear patterns, remember, which look something like this. Maybe the nth term would be 5n plus 7, right? And we've also talked about quadratics, which might look something like this, where we have an n squared minus 3. Okay, these patterns today are going to look a little bit different, but we're going to use the same techniques we've been using to find them. Here's our first example. The pattern is, or the sequence of numbers 0, 7, 26, 63, 124. Notice I've already filled them in. Okay, I'm going to find my first difference. And so I got plus 7, and what is that, 19, and hold on one. Okay, and that difference is 37. Okay, and then I believe I have 61. Okay, so now that didn't yield anything, so I go down to the second difference. Remember, I want the difference to be the same number over and over. So there's plus, what, 12, and I believe that is going to be plus 18, and that's going to be plus 24. That didn't yield anything either. So we'll go down to the third difference. Okay, and we're going to go plus 6 and plus 6. Oh, and you notice how we keep getting the plus 6. If I would find the sixth term and go all the way down to the third difference, the third difference on the between the fifth and sixth terms would end up being plus 6 as well. So since I'm on the third difference, my exponent is going to be 3. So my formula is going to be something like n cubed. It may be n cubed on the nose. It might be some form of n cubed plus 7, n cubed minus 10, something like that. So I'm going to put these numbers in for n and then compare them to the original sequence. So 1 cubed is 1, 2 cubed is 8. All right, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. Now, those of you that totally get this, I know you can see already that to turn the red one into the black one, I need to subtract 1. So that's true in all the cases. So my formula is n cubed take away 1. All right, to figure out 31, I'm going to do 31 cubed, and I'll subtract 1 from it. Hold on. So when I plug this into my calculator, I end up with 29,790. 29,790. Okay, so, and I don't have this box big enough, but that's okay. When you do it on your paper, you can be sure to make it large enough. Okay, so our pattern, our nth term ended up being n cubed minus 1. And we call that a cubic pattern. That is a cubic because the highest power is 3. All right, so we have linear, we have quadratic, and then we have cubic. All right, why don't you go ahead and try number 2 on your own? It's done very much the same way as the previous one, if you want to go back and rewind and watch that part again, and see what you can come up with. If you're still watching at this point, I assume you want to see my solution. So I'm going to find my first difference. What I got? Plus 7. Looks like plus 19. Plus 37, yeah. And plus 61, right? Second difference plus 12. Oh, this is looking familiar. Plus 18 and plus 24. And there we go. The third difference is plus 6 every time. Okay. So it's some type of n cubed. Again, I'll work smart, not hard. I'll just 18. Mental blank 27, yeah. 64 and 125. And it looks like each time I'm adding 5, right? Adding 5 to turn the red ones into the black ones. Okay, so my formula is n cubed plus 5 cubed plus 5. This is a cubic. And then, of course, I have to cube 31 and then add 5 to that. And I'm not really good at cubing 31 in my head. I've got a lot of little number tricks, but that's not one of them. And so the 31st term, 29,796. Yeah, 29,796. Okay. So let's go down to this one here. And you notice I've given you a 6th term before I go on for my nth term. And you'll see why in a minute. Maybe you can figure out why. Again, I'm going to go for the first difference, and it looks like it's plus 15. Let's see, 83 minus 18. 83 minus 20 would be 63. 2 more is going to be 65. Okay, what is that? 258. So over here I got 258. And I'm going to take away 83. So I'm going to get a 5 and a 17. So that's 175. Oops, moved out of right mode there. There we go. Okay, now I have 627 minus 258. Yeah, I'm going to have to do a little borrowing. So I got 17 minus 8 is 9. And let's see, that'll become a 5, 11. We're going to get a 6. We're going to get 369. This one here is 369. And this one we have 1298 minus 627. And we're going to get 1, and we're going to get 7, and we're going to get 671. These things are very far apart. Now, by the way, see all this work here that I'm going to erase? I don't ever want you to erase it. I'm only erasing so I can keep it all organized here, and you can always review and see it. But when you're doing this kind of work, that little subtraction work I just did on my paper, I don't want you erasing it. All right, so let's see here. Oops. There we go. That's going to be plus 50. And that's going to be 110. Okay, what do I have? 369 minus 175. So 184, I think. No, 194. Yeah, 194 looks right. Okay, so 194. And the third difference, I'm sorry, the second difference, 671 minus 369. Looks like it's going to be a 302. Still very far apart. So I'm going to go down to the third differences. All right, and that's going to be 60. And that's going to be 84. And let's see if it was 300. That would be 106. I think it's going to be 108. And then when I come down here, I get a 24. And this is also 24. So that's the first, the second, the third, and the fourth difference. So this formula is going to have an n to the fourth power. By the way, this pattern would hold. Like if you had to go down to the 12th difference, you would get n to the 12th power. Now we're not going to see anything this advanced, like 12th power or anything like that, but I think it's good to understand what's going to happen. All right, so 1 to the first is 1. 2 to the first is 16. And again, I'm sorry, 1 to the fourth is 1. 2 to the fourth is 16. 3 to the fourth is 81. And 4 to the fourth is 256. And, you know, checking those 4 will be sufficient. If I check 4, I'm going to get the right answer. As I look up, it looks like the red ones are all 2 less than the black ones, the original. So I have to add 2 to the red ones in each case. And so this will be n to the fourth plus 2. Now to figure out this one, I'll do 31 to the fourth power, which is going to be a humongous number. It's going to be really large, and then I'm going to add 2 to it. All right, so let me see here. 31 to the fourth power is 923,521. And when I add 2 to that, I get this number here, 923,523. Oops, didn't quite make it on the page. Let me shift it over and put a 3 on there. This is the answer right there. Okay, 923,523. This was an n to the fourth plus 2. And when it's to the fourth power, you don't see this very much, but it's called quartic, kind of like a quarter. So we've talked about linear, cubic, quadratic, cubic, and quartic. All right, one more. And again, you can try this one. Go ahead and pause it when you're ready. You can see the final answer. I'm not going to go through the whole thing, except, okay, you go ahead and try. Hope you haven't worked too hard just yet. I just caught a mistake. The fourth term should be 252. Sorry about that. Okay, so you can see I'm starting to put some work in here. You can go ahead and pause and get back to work. My differences will show up. Okay, so there's my first and second differences. I'll keep going, and I'll get 60, and then what's it, 84, and then I have a mental blank, 108, I believe, right? And this is 24, and this is 24, and again, I'm at the end of the fourth power. Okay, so now that you know it's end of the fourth, see if you can come up with the rest of it on your own. Go ahead and pause the video. If you're still watching, I'm assuming you want to see it. And this one's a little bit different. It looks like for the first one, I have to subtract 1. For the second one, I have to subtract 2. For the third one, I'm going to have to subtract 3. For the fourth one, I'll have to subtract 4. What am I going to have to do for the nth one? I'm going to have to subtract n. Absolutely. So my answer is going to be n to the fourth minus n. So to do the 31st term, I'll do 30. 1 to the fourth power minus 31. And that comes out to be a very large number, as you can expect. 923,490. And I did it again. I ran off the page. No problem. I'll slide it over and sneak my 0 in there. All right. So the formula was n to the fourth minus n. And again, that was quartic. All right. Mr. Lawrence signing off. Have a good night, everybody.